Why, hello, and welcome back to developing Tetris. Um, where we left off is we kind of just have a blank program that runs SDL and it can work, but there's no functionality other than hitting the escape key. So from here, I'm kind of looking at stylistically how I want to approach it, and I feel like this and this kind of will be what I'm aiming for anyway. The small little changes in the color kind of around the edges I'm not going to worry about right now, but so it'll be more like this. However, we can go back um, and make things look better. So looking at this here, this is a 12 by 22. Um, that works for me. I just need a kind of number at first. So that's going to be the outer perimeter and kind of the area of what we're going to work with. So the next thing that we have, since we have a game controller, we have a main. I would say the next thing we want is a game board. And so that'll be some object that'll store the state of everything that exists within this game board. So let's start to make that. Okay, so now we have our game board header and C++ file. Let's go ahead and start defining what a game board object should have. So I'm going to store the state of this as a 2D vector of certain cell types. We'll probably have an enum that we'll create in just a moment of, say, wall, um, block, and empty. For now, I'm just going to throw it in the game board header, but we can always change things as we go. So this is going to be an enum for cell underscore type. And then in here, I'm going to have none. I'm going to have wall, and I'm going to have, say, block. Gonna quick include gameboard.h. We're gonna need a vector to store the kind of game state of this. So this is going to be an std vector of cell type. So this is again a 2D vector of certain type called cell that we just defined up here, and we're going to call this, say, game board vector. It can get confusing with naming, so I try to be as verbose as possible. So here, let's start defining the constructor for game board. Let's quick add an initialization list of just this, make it empty. Once we create our game board object, we will only ever have one game board vector for each game board object. We should only ever have one game board anyway, but what we're going to do is let's create some initialize game board, if I can type vector. Let's just have some function that will, it doesn't need to be public. Nobody's going to have to access this. Thing we're going to need to give as information into the game board vector, and perhaps we want to store it, is the screen width. So int screen width pixels and screen height pixels, or you could make it a constant since technically it will be constant 1920 by 1080, but let's just for sake of it pass it in. And then in our initialization list, we can now just, as I commented before, we're going to do a 12 by 22, but theoretically that could change, so it begs the question, who should dictate that? For now, I'm just going to have those as constant. Cell width should be 12. Let's say number of cell widths. Number of cells width, that communicates enough to me. Numbers, no, not numbers. Number cells height equals 22. So now that we have everything set up for initializing the game board vector, there's a couple different ways you could do this, and some probably would be a little bit easier for implementation wise, you could just do, since we're setting these constants, we could just initialize it here, but for sake of readability, I'm going to do it here. So we want the vector to be, suppose, this is our game state, and we want the vectors to go, the first index being what row, and then the second being what column. So for that, rows are equivalent to height. So we're going to do for int row equals 0, row is strictly less than number cells height. So this would be height 0 for the row, this would be height 1, etc. And then we're going to continue this row plus plus. And then for int col equals 0, col is strictly less than number cells width, col plus plus. Could do plus plus col either way. And then we're going to, for each row, have a std vector of type cell type. We're just going to call this temp. And we're going to just, for now we can just push back temp.append, or push back anyway, cell type none. And then after that we would just game board vector dot pushback temp. So this is quite inefficient. This is allocating all this memory, 100, I think default is 100 capacity for a vector. It's allocating each time, and then pushing these elements, and then pushing them there, and then reallocating. So it's very inefficient, but I think anybody who reads this can probably understand what we're going for. And I would argue, especially on such a small scale as Tetris, that that's probably worth, detriment to speed and everything, making it easy to read. So, okay. So now that we have that, let's start the process of displaying our board. Let's add that to our header. We'll probably want to make that public because someone is likely going to need to call that. So for this, we actually are going to need the STL renderer pointer. And for that, we can include in here stl.h. There's probably other ways you can go about it, but this is how I typically do, and this works for me, so that's what I'm doing. Okay, so given the renderer and we have an assumed initial game board, we can use some math to determine precisely how to draw the board on the screen. So to do that, we're going to double for loop again by row and call. This time we can just use gameboard vector dot size. Notice here we're doing dot at 0 dot size just to get, since it's a symmetrical vector, we know the size at 0 will be the size for any row. I suppose you could use row here, but regardless. So for sake of more readability, more organization, I'm going to create another function. I'm going to call draw game board at indice. And this will take our renderer, our row, and call. So let's add that here. We shouldn't be changing row or call. In this, we can make them const, just to const references, that is, just to communicate to any other programmers that we don't intend to change this, but we're passing it as const references so that we don't have to copy it and copy the memory value and the address. We just use the address, but don't change it. So now let's do the definition on the C++ side. At a given indice, how do we draw a block? So what we're going to need is an STL color. Call it C. I'm going to call it color to be verbose. We're just going to initialize that to zeros, except for the alpha channel. So this will be a color storing R, G, B, and alpha values. So we're going to initialize it to all zeros except for the alpha. Down here we're going to eventually have different kinds of blocks, different all that, but for the moment, let's just have a switch on the current type of block. So what we're going to do is, again, sake of simplicity and readability, and it will be public just in case somebody needs to call it. If not, we'll change it later, but we're going to create a inline cell type, say get cell type at index at a given int row int call, and for this we're just going to return gameboard vector dot at row dot at call. Forgot that there. Perfect. And again, so we don't plan to change this, so we can make these const int references. So let's switch on this case that suppose cell type was none. We can configure what colors we want each block to have for now, but let's suppose that for none we just want white. We're going to have a default case where we just break. But we should never hit that, but just for readability, having that there. So at this point, we've switched on the cell type and created some sort of color for whatever cell type that is. So from here, we're going to STL set render draw color to be the render. We're just going to do color.r, color.g, color.b, color.a. So let's tell the renderer this is the color we want to use. And let's create an STL rect, call it current block rec. So this is going to be the actual individual blocks here. Each individual block will have its own rect. Jeez. Okay, so let's start configuring the rect. We have an x, a y, a width, and a height. So for our x, let's do some math. One thing we're going to need is the width and height in pixels for a given cell. So since we're going with a square design, the width and the height should be the same. So what we're going to do here is we're going to, judging by how this looks, this is about a third of the screen. So I'm just going to do that the x value, we can do int, we could actually just make this int cell width pixels, and then initialize this to be the screen width in pixels over 3. Somewhat arbitrary, we're just going to see how it works out. Multiplied by the number cells width. Forget a comma. To me that's, oh, sounds right at the moment, but let's find out. So we're going to say cell width pixels multiplied with whatever column we're at. So this will offset the current column, whatever we're drawing, by whatever cell we're drawing, we're offsetting it by whatever column we're currently at. I guess I'm stylistically going to approach it more so like this, where each block is surrounded by a certain thing. So we're going to do another, say, const here for now. Const int line between cells offset equals, say, 1 pixel as that border, but we'll change it as necessary. So we're going to add line between cells offset, and that should be our x value. Current block rec.y should be likewise with the cell width, since they're square, should be the same, multiplied by row, plus likewise the line offset. The current width should be just equal to whatever our width is, less the offset, and likewise for the height. So now we have to SDL fill render fill rect with the current render, and then a pointer to our current block rec. Right, so now that we have this set up, to draw the board, we need to actually add the game board object to our game controller. So I'm going to create, one thing we're going to need is memory, because I will be using a smart pointer, std unique pointer of type, something we can just forward declare the game board class, and we'll make it of game board. I'm just call this game board pointer. So here we have now a new member, game board pointer. And now in our initialization list, we're just going to add game board pointer. Oops. Okay. Of course, make sure to include gameboard.h. And now we should be able to compile. And we do. So now we have everything set up. Let's use this new draw functionality. So I set it such that every cell which is none, which should be the entire game board, should be drawn as white block with a black line in between each block, that is. So now, after each frame, let's just draw it. So gameboard object, gameboard pointer rather, dot get, because it's a smart pointer, so this is how you actually get the pointer. And then using pointer notation, arrow draw gameboard, given a render. So now let's just see what happens. Uh-oh. So what we forgot to do here was SDL render present, given the render. So this function will actually, given a render, present it to the screen. Without that, it doesn't ever get put to the screen. So, drum roll. Okay, so I realized in my head, thought division did multiply. So it's not actually it's not multiply here, it should be divided. Because we have, say, this section of screen, and then the pixel for each one would be that section divided by how many cells that we have. So now if we compile, awesome. We see that we have a grid that gets cut off, but I mean, this is farther than we were before. So we only display seemingly 21 out of our 22 blocks. So I'm going to see if I just change this instead of being width. Okay, so I had to play around with it a little bit, but I figured out that what I was really wanting to do was do the height in pixels by the amount of cells in the height, 22. So now we get this beautiful grid. This is our game board. So one thing I want to do is I want to make this game board centered, and we do that by messing with our X here. So I think I can make it a somewhat magic number, not very good, but let's do the screen width in pixels over 3, rather over 2 to get it in the center, and less the half of the width in pixels. So let's do number cells width multiplied by cell width pixel. So let's see what this gets us. Not necessarily it. Right, we want half of this. Might be just it. Okay, perfect. So I'm just going to draw this out to be more telling of what just happened. So suppose now we have our screen, from 0, it's far too wide. So suppose we have our screen and it goes from 0 to width. Half of the width will be width over 2, which would be roughly center of our screen. However, if we were just to offset our rect's x value by that much, we would see that our game board would start there, and thus we'd see this, as our game board. So really, we want to know what this is in half, and then if we take our game board size, which let's just say this is our game board, this also has, say, some 0 to game board width. So we want to know the midpoint of that. So this would be GBW over 2, such that we can, and this is a drawing of this up here. Here's GBW over 2, such that we just subtract from this offset of the middle of the screen, subtract that such that this middle point gets moved over and aligns here. This middle point would align here, the start point would move over here, and that. So that's what we have happening right here. We have the full screen width over 2, so we get the midpoint, and we get the midpoint of our game board in pixels, and then just subtract the midpoint of the screen by the midpoint of the pixels, and that will get our offset such that now our game board's right in the middle of the screen. Okay, so I'm going to say that will be the end of this video. We successfully created a game board object, set it up with all the different things that we need, and we're able to add it to our game loop such that it's drawn every time the game is called. So yeah, thanks for watching.